Right now, at the very edge of everything we can see, space itself is running away from us, accelerating, pulling galaxies apart at 67 kilometers per second for every megaparsec of distance, and something on the other side of that edge is shoving it. We don't know what. We don't know why. But here's what we do know. Our universe isn't alone. Turns out some of the most rigorously tested models in modern cosmology, eternal inflation, string theory's landscape, loop quantum gravity, they all point to the same thing. Our universe is one membrane stretched across an 11-dimensional bulk of space we can't see, can't enter, and can't measure. And that bulk? It's not empty. It's crowded. Picture an ocean. Now picture every bubble that has ever formed in every ocean on Earth, simultaneously, across the entire history of the planet. Each bubble, a complete universe. Its own physical laws, its own time, some with different constants of gravity, some where atoms never got the memo to form, some that collapsed before a single star ever lit up, and some moving toward each other. Here's the question that keeps physicists up at night, and I mean that literally. What happens when two of those bubbles touch? Not if, not hypothetically. Some cosmologists think it may have already happened, that there are literal bruises pressed into the oldest light in existence, scars left by a collision that went down before time had even fully decided what it wanted to be. Stick with me here, because what I'm about to walk you through isn't science fiction. It's the most extreme event that the laws of reality actually permit, and it ends somewhere far stranger than destruction. First, let's get clear on what we're actually dealing with here. Our universe is, at minimum, 93 billion light-years across, and that's just the part we can see. The full thing, the part beyond what light's had time to reach us from, is probably hundreds of times larger. Some estimates say it's infinite. That's what we're talking about, colliding with something else. Now, here's what nobody tells you about a universe collision. It wouldn't happen fast. There's no crash, no bang, no fireball rolling outward like some Hollywood explosion. It would start at a single point of contact, a geometric kiss between two membranes, each one carrying a universe on its surface. And from that point, a domain wall, a boundary between two completely different sets of physical laws, would begin expanding outward at the speed of light. In 1 second, it crosses 300,000 kilometers. In 1 minute, it's swallowed the equivalent of the Earth-to-Moon distance 900 times over. It doesn't announce itself. There's no visible shock wave running ahead of it. No heat you'd feel building on your skin before it arrives. It moves at exactly the maximum speed information can travel, which means you get zero warning. The first moment you'd know it was coming is the last moment you'd exist in a universe with your physics. But here's where it gets crazy. That's not even the terrifying part. Imagine you're standing outside, ordinary Tuesday afternoon, and then imagine that the constants of physics, the specific numbers that determine how strongly electrons bind to atomic nuclei, how massive a proton is relative to an electron, how quickly gravity weakens with distance. Imagine all of those numbers just changed, not slowly, not gradually, instantly, across a boundary moving at light speed. Here's the thing. On the other side of that wall, the fine structure constant, the number that governs how tightly matter holds itself together, might be just slightly different. And slightly here isn't a rounding error. It's a catastrophe. A shift of just a few percent in that constant means electrons no longer orbit nuclei at stable distances. Atoms don't form, or they form in configurations that refuse to bond into molecules. Chemistry doesn't slow down, it ends. Every atom in your body would still exist. They'd all be there, but they'd stop cooperating. Your cells wouldn't explode, your molecules wouldn't burn, they'd just disaggregate. The forces that convinced your carbon to be you instead of a gas or a rock would quietly withdraw their cooperation. In a universe with slightly different physical law, you aren't killed, you're reclassified. And it gets worse. The domain wall doesn't care about galaxies. It passes through one at the speed of light, and on the other side, every single star in that galaxy is running a different equation for nuclear fusion. Some go cold, Some flash supernova simultaneously. Some collapse into configurations of matter we don't even have names for yet. An entire galaxy, hundreds of billions of stars, unmade in roughly the time it takes light to cross it. About 1,000 years, that's it, for a whole galaxy, gone. But wait, here's what nobody tells you about this part. We might not be the ones getting invaded. Here's the thing that reframes everything you just heard. The collision goes both ways. When two membranes meet, the domain wall expanding outward into their universe is simultaneously expanding outward into ours. There's a wall moving away from the collision point in both directions at once, one consuming their laws, one consuming ours. We are the catastrophe for them. Think about that for a second. On the other side of whatever boundary is pressing against our universe, if there's a civilization sophisticated enough to detect cosmological anomalies, their physicists might already be watching a domain wall approach, running their own versions of these equations, their equivalent of string theory or eternal inflation spitting out the same answer, that they are about to be rewritten by us. We're the alien invasion. We're the extinction event arriving at the speed of light, and we don't even know we're doing it. Now, here's the one breath of perspective I can offer you, and honestly, it's genuinely beautiful, even as it's strange. The probability that this is happening to us right now, in the next few billion years, is considered pretty low by most cosmological models. Not impossible, just low. Our universe appears to be in a phase, possibly a metastable phase, but still, of relatively stable vacuum energy. The kind of universe where domain walls aren't exactly knocking at the door. For now. But here's what scientists found next, and it changed how they think about basically everything. In 2015, a team of researchers ran a systematic analysis of the cosmic microwave background, the faint afterglow of the Big Bang, the oldest photograph of reality we have. And they were looking for something specific, circular anomalies. Because here's the thing, if a domain wall from another universe grazed ours during the inflationary period, the first fraction of a second of existence, it would have left a mark. A spherical bruise pressed into the plasma of the early universe. A ring of altered temperature, slightly cooler or warmer than everything around it. They found candidates, 4 of them, circular, unexplained by standard cosmological models. Not definitive proof. Science is honest about that. The statistical significance wasn't enough to call it confirmed. But they were there. And get this, those anomalies were pressed into the fabric of the universe before the first atom formed, before the first star ignited, before time as a sequence of events had even fully committed to its own direction. Whatever grazed us, if something did, it happened before we were anything recognizable as a universe, and we survived it. Which means collisions don't automatically mean total annihilation. They can mean transformation. Some theoretical models suggest that right at the collision point, the zone of contact between two membranes, a third region could form. A hybrid space, not our universe, not theirs. A pocket running on some superposition of both physical law sets, not destroyed, merged, new constants, new chemistry, new physics that neither universe generated on its own. It wouldn't be survivable for anything that already existed there, but it would be generative. Potentially across the aeons that followed, it would be creative. In the mathematics of multiverse collision, apocalypse and Genesis are the same event, viewed from opposite sides. Here's what I want you to actually sit with for a second. Everything we've ever built, every cathedral, every equation, every song, every grave, every first word a child has ever stumbled through, all of it exists on a membrane, a surface. A film of reality stretched across a geometry we can't perceive and can't enter. And that membrane isn't sitting still. The universe we're inside of is moving through something. Something with structure. Something that contains other universes. Other membranes. Each one carrying its own complete version of existence. Its own version of history. Its own version of loss. Some of those membranes are moving toward each other. We don't know which ones. We don't know how fast. Our instruments are pressed against the inside of our own bubble, and we're trying to infer the shape of the entire ocean from the texture of the water touching our shore. But here's the single most staggering thing. and I've been saving it for right now. The vacuum of our universe, the empty space you walk through every day, the stuff you think is nothing, contains energy. It's called vacuum energy, or the cosmological constant, and it's what's driving the whole universe's expansion. That energy exists at a specific level, a specific value. Physicists call our vacuum metastable, which means it's stable, but not at the lowest possible energy level. It's like a ball resting in a valley on the side of a hill. Comfortable, not going anywhere, but not at the bottom of the hill either. If something, a high-energy cosmic ray, a random quantum fluctuation, or the touch of a foreign universe, gave that ball even the slightest nudge, it could roll down to the true vacuum, the lower energy state. And from that single point, a bubble of true vacuum would expand outward, at the speed of light. The physics inside it, incompatible with atoms, with molecules, with stars, with life, with anything that currently exists. This is called vacuum decay. And it is, by a significant margin, the most complete form of destruction that physical law allows. You can't stop it. You can't detect it coming. You'd never know. One moment you exist. The next, the laws that define you no longer apply to the space you occupy. Nothing. Absolutely nothing. And here's the part that genuinely keeps me up at night. The reason physicists think a universe collision is the most likely trigger for vacuum decay in our universe isn't because the collision itself destroys us. It's because it doesn't need to. It just needs to deliver enough energy to one point in our vacuum to tip the balance. One nudge. That's it. That's the whole thing. Two universes collide and the collision itself might actually be survivable. The physics rewrite might be survivable in some transformed sense. But the knock-on effect, the vacuum decay that gets triggered by the impact, that's what closes the book. Here's what I keep coming back to though, every single time. We live in a universe so precisely tuned for complexity that the emergence of creatures capable of asking these questions feels almost deliberate. The fine structure constant, the gravitational constant, the mass of the electron, tweak any one of them by a fraction of a percent in either direction, and none of this exists. No stars, no chemistry, no thought, no one to notice. We are, in some real sense, the universe looking back at itself. And what it sees, when it looks honestly, is that it's fragile, temporary, resting in a metastable valley, surrounded by an ocean it can't fully see, on a membrane drifting through a geometry it can't enter. And yet, it builds cathedrals, it writes equations, it falls in love. It looks up at the night sky and asks, what's out there? And honestly, that's not nothing. That might be the most extraordinary thing in any universe. If that left you genuinely unsettled, and maybe a little astonished, subscribe. There's more where that came from, and the next one goes just as deep. What actually happens if two universes collide? Two universes collide, and the result isn't just destruction, it's transformation.